Let's add our interfaces to our library. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Now what I'm gonna add in this video may look confusing for beginner programmers on Minecraft API. I will try to explain what I'm doing and why I'm doing things, and later when you learn about block entities and their functionality and more knowledge about block entities, come back to this video and some of these interfaces makes more sense for you. For those who know everything about block entities, that's okay. The first interface that I want to add is iDelegate provider. This is the naming convention from C#. They use the I keyword at the start of almost every interface, and I like it. Most of the time I use it. There are few different places that I may not use it, but most of the time I use it because just by looking at the name later in the code, I know that, hey, this was an interface, Now, delegate provider means that I will implement this interface in a block entity that will have property delegates. Now, what is a property delegate? Property delegates are some attributes that you add into block entities by index, and you can track them by index. For example, if you have a progress and a max progress, these are two properties that you can add to the block entity and index one of them as 0 and the other one as 1. And then you can ask, hey, property delegate.index 0, what is your value? You will not use that inside the block entity class because you have directly access to the progress and max progress values. But when you are writing your GUI, yes, you need to have access to those values based on property delegates. And as the name suggests, it's a delegate that represents properties. Now, if any block entity has a property delegate, you want to have few methods in it. And all I'm doing here is putting the skeleton for those methods so that when I add iDelegate property interface, that reminds me that, hey, you need to write the code for these methods. Okay, the first method will return a property delegate, and we call it get delegate. The next one will return an int, and that is get delegate size. And this is it. So whenever I implement iDelegate properties, I have to override these two methods in it. The next one, now this one is interesting. The concept was provided by Turtivorti. Basically, we have block entities that we want to automatically sync the data between the client and the server. And we want to make sure that data is synced between client and server. Now, here is the thing. If we want to make that sync happen, we should know what are the things that we want to sync. Basically, if we want to make the sync happen, we have to have two different methods. One is to do the sync itself, and then another method that would tell us what needs to be synced. This interface will provide only the sync method. So void sync, and that is it. However, I may change it in future, but I'm not sure. Actually, I think I will do this. I will return a list of iSync, and we call it get syncables. So what I'm doing here is that I am telling that, hey, you know what? I want to make sure that whatever I'm doing, I need a list of things that are implementing this interface. Now, I'm debating on keeping it here. Actually, let's have it there and make the decision about the API changes later. The next one is actually interesting. We know that block entities tick 20 times per second. So what I want is an interface that identifies the block entities that can tick. Because yes, block entities tick if we want them to tick. There are chances, really limited use cases, that you may have a block entity and you don't want to tick that block entity so often. This interface is about the block entity ticking. And of course, we will have a void called tick. One more thing, when you are creating a block entity that is tickable, you have to create that reference to the tick method on the block entity when you are writing your block. If you look inside my blocks, for example, the GUI, you see that the GUI base actually is using this abstract activatable block, but get ticker. Get ticker means that you need to address what is the tick method on the block entity. Now, normally in vanilla way, you have to check if the word is null or if it's not the client and stuff like that. However, I want to cover them here. That makes my life much more easier. So I say static that returns t extends block entity from net Minecraft block entity. And then we want the block entity ticker of that block entity as the return. And we call it create ticker. We have to send the word in. And unlike C#, normally in C# we don't implement any method bodies, but in Java we can do that. So return if the world.isClient is false. So if we are on the server side, we want to send in parameter world, the position of the block state of the block, and the block entity into a method that is called tick. Now this tick is on the entity, but now we need to make sure that the entity is an instance of our interface. If the world is actually the client, we return null. This means that on the client, our block entity will not tick. Now you may ask yourself, why shouldn't we tick the block entity on the client? Remember, the client is responsible of playing sounds and showing the interfaces, stuff like that, drawing and rendering. All the logic that belongs to a block entity is on server side. So when you tick the block entity, normally what you're doing is that you're handling the logic. Honestly, I prefer not ticking the block entity on the client because the use cases for that is really rare. And if you have a use case for that, you can add another method here called tick client, and instead of tick, you will add another void tick client, and then here you will call that tick client for the client side if you so want to. I'm not sure. Let's add it to client, because I think the only way that I would want to have something like this, I don't know, is to play a sound when the machine is working, for example. I'm not sure. But hey, now we have it. We can leave it empty as it is in our implementations. So we have a default block state, and we say get state. This is a helper method that I want to have on every instance of a tickable block entity. Now here we have a word, we call it word, and a block pose. Why am I adding it? Because sometimes I forget how to write this. If the word does not equal to null, we want to say word dot get block state from the post. You say, you forget this? Yes. Sometimes I forget the usage of the word there. And I was thinking like, hey, how do I get the block state on the position? What was the way? Yeah, that's my brain working for you. Having this method, now I know that, hey, I need to send in the word. Okay, I remember everything. A little useful helper method there. It doesn't harm anyone. Now, the next interface is an extension on iTickB, and this is why I was debating on keeping that syncables in iSync, but let's write it. So this is a Java class, an interface, we call it iTickSyncB. Actually, I synced tick, and I will remove that BE from the end in both cases. So iTick and iSynced tick. So inside here, we extend this from iTick, and because we are extending it from iTick, we have access to tick and tick client. Extend iSync, I think. Now we have access to that get syncables here. We have the tick and we have the tick client. However, we want to have a new class, void on tick and void on tick client. And we are overriding that tick method. So we are overriding the tick method ourselves as the default implementation. Now here we say, first of all, please call that on tick for us. And then we say if get syncables does not equal to null, and not get syncables dot is empty. So if we have any values there, we go into syncables and we run for each isync colon sync. So we call the sync method on those syncables. Then we say if this instance of something that we don't have yet, no screen updatable block entity, and we call it block entity. So if it's instanceable of a block entity that is updatable but has no screen, and we will talk about updatable block entities in future, don't worry, but if it's an instance of that, we say the block entity, please call the end tick method on there. And honestly, I want to get rid of this, so I will produce another interface and I call it iUpdatable. And all we are doing here, we call void on on tick end. That makes much more sense without tick end, on tick end better. Even end tick is not interesting. So if it's instance of iUpdatable, and we call it updatable. So we call updatable dot on tick end, and that's it. So now I dissected the usage of a class and I'm using interfaces now. Again, this is a change that I did on 30 Vortis code. And yes, the sync and tick and sync tick, I think these three are provided by 30 Vortis. So I will go and take the code for giving the credit. I sync, I'm sure. I tick, I'm sure. And then the synced tick, yes, he added that code somewhere. Updatable, that's from me. Okay. So here's the thing, tick, we call the methods with the on, if you look. But for the tick method, I will just keep them as that because these are events. Normally, when you start the name with on, you are talking about events. These actually are not events in my code, but these are things that will happen inside the tick method. So that's that. Now, I will have something like the same for the tick client, and here we call on-tick client. Of course, now we don't want to sync things on the client side, but I want to have this on-tick client end. So I will not have that, but on-tick client end for whatever reason, just making things more complete compared to what they were. The next one is again something that was provided by Turtiburti, and that's another interface. He called it NBT serializable. I will add the I at the start, so I NBT serializable. Honestly, I hope it works from the start because things has changed related to NBTs inside 1.21.5, and it's an interface. I forgot that one. Okay, now this use generics. T extends NBT element. Here we will have a write NBT and read NBT. So T write NBT registry wrapper dot wrapper lookup, and we call it registry lookup. And the other one is void read NBT with the T as the NBT and again the lookup. I may need to change this because I think stuff had changed inside 1.21.5 and I'm not sure if it's only register lookup. Okay, let's take a look at the blog for 1.21.5. There is a section that they are talking about NBT. So they are not talking about this signature of the methods, but apparently NBTs are now returning optional. So when we had int value and we were checking if the value is there, then we would assign a value from the NBT, or we would assign a default. Instead of all of that, now we say NBT.getInt, and NBT compound config equals to config, for example. Now we say compound or empty. Finally, for those who want to encode, decode codec-based values, such as identifier, stored in an NBT compound, new methods simplify the process. So we say, hey, just use the codec and the value. And when we are reading it, we use the codec. And if there is a codec for the whole object instead of the value, so for example, I don't know, if you are setting an item stack inside an NBT, so we say copy from codec, item stack map codec, wrapper lookup, so it should be there, .get ops for NBT ops instance, and put the stack there. And when we are reading it, we decode the map codec and again with the NBT ops instance. Typed arrays, byte array, int array, and long array are no longer lists. They can be converted to a list using .stream.list, but this is usually not necessary. NBT list can now contain values of different types, but this should be a transparent change unless you work with binary data. Okay, so I think this simplifies my code a little bit. The main change that you need to remember is that we were getting a value, now we are getting an optional of the value. So let's move forward. This should work actually. The last interface will sit under client. So I will add a Java class and interface, and that is iIngredient renderer. This will be used when we want to render an ingredient. And of course, we are using a generic type here because we don't know what is ingredient. So we say a default void, we call it render. This uses a matrix stack from Minecraft. We call it a stack. The ingredient as the generic type. Here we call render with the stack, comma 0, comma 0, and ingredient. Of course, this is an overload that we need to write. And this is exactly what we want. So we say default void render with the matrix stack, then int x and int y, and then t ingredient. And this is an empty method. By providing the method, we are preventing it from causing any problems, telling us to implement the methods and stuff like that. Then we have a method that returns a list of text from net Minecraft text, and we call it tooltip, t ingredient, item.tooltip, context, tooltip, context, and string mod id. This is a method that needs to be implemented all the time. So the next one is default text render, font renderer from Minecraft client, we call it client, and t ingredient. We say return client.text renderer, then default int width, by default we return 16, default int height, by default we return 16. So basically we are making sure that by default we are drawing something as 16 by 16. That's the default slot size for inventory. This is the interface that we will implement when we want to render any ingredient in our GUI. And that's it. Basically, we finished implementing our interfaces. In the next video, we will come back and talk about block and block entity classes. These are implementations that we will use later in other libraries, but at the same time, we are already using them in our main mod. For example, abstract activatable block. This means that we have a block that has a property, a Boolean property for activation. And other things, for example, the machines are using abstract machine block. Now, this comes much later after we finish this library and after we finish the fluid energy and inventory. When we are writing gmachina, then we have the machine block. However, before that, we need to finish this library and few other libraries. They are not complex, but they are time consuming. We will see what is going on in the next video. If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.